Welcome to the Polygonology game, a unique training exercise focused on the issues associated with convective warning polygons and associated text products. The purpose of this exercise is to help forecasters recognize these issues in future events and make corrections when and where possible. I'm Pete Wolf, the Sioux in Jacksonville, Florida. I designed this exercise in early October of 2022 in recognition of the 15th anniversary of storm-based warnings and their infamous polygons. This training exercise focuses on many of the issues seen with WarnGen, not just 10 to 15 years ago, but even in the current year. WarnGen was designed to add an additional minute or two of lead time because of a more efficient approach to text product design and issuance. However, because of the issues that can occur with the polygons and associated text products, one really needs to use that minute or two to review and correct the text products as needed to transmit a more beneficial result. Wrong or confusing information does not support good decisions by those receiving the warnings. In this short exercise, your task is to complete 12 short scenarios. Each one should take 1 or 2 minutes, so completing the exercise and the grading of it should take about 30 to 40 minutes. Each scenario is a real-life case example from the period 2020 through 2022, with the actual polygons that were drawn and issued by different forecast offices across the central and eastern United States. You'll go through the scenarios using this video and an accompanying PowerPoint answer sheet file. You may be asked to draw new or updated polygons or recognize issues with the text products. When you're done with this exercise, you'll access an answer key video with instructions on how to self-score your answers. You can earn up to 5 points per scenario, thus your max score possible is 60. You'll add up your scores for each of the 12 scenarios and compare your total to the table shown below. Now your goal is to score in the 40s or 50s, hopefully not below 40. But even if you do, the real purpose of this exercise is to learn about the issues that can exist so you can recognize and correct them in future events. Here is a case example for illustration on how to provide your answers on the PowerPoint answer sheet slide deck. So if you're asked to draw a new or updated polygon, you would simply go up to the shapes and choose polygon right here. And then you could draw your polygon. You just click one point at a time. So if in this example I want to remove area behind the hazards where there's no longer a threat, I could just highlight my new polygon as I'm doing right now. So just highlight the area you want, connect the dots, and you can change the filling if you want. And that's really all there is to it. If you are asked to provide text answer like errors that you recognize in the polygon or in text products, you can just simply click on below the question. There should be an answer section there and you just type it in. So pretty simple. Now there's no way to meaningfully incorporate the stress of warning operations into this exercise, which can be a key source of mistakes that are made. It is suggested, however, that you only spend 1 or 2 minutes on each scenario. Don't spend 5 minutes on one since you don't have that luxury in an actual event. So are you ready? Let's get started. Here's the first scenario. For this eastward moving tornadic supercell in a high shear environment, how might you refine this tornado warning polygon to better highlight the area of danger and remove areas that are not really in the path of the storm, and particularly the path of the mesocyclone that's indicated by the curved arrows? How many locations listed in the text product can you remove because they're not in danger and you don't want people there unnecessarily taking cover? Please note that the straight white arrow illustrates storm motion that has been persistent over the past hour. The hail core overhangs over the inflow notch that's shown, while wind potential exists with the rear flank downdraft just south of the mesocyclone and within the forward flank downdraft area. Also note that the red lines at the top of the text product hide the states in an attempt to keep the local office anonymous, although this will not always be possible. The red lines hiding towns in the locations impacted section remove ones that are so small that they're not even seen on Google Maps, thus I don't really know where they're located. Go to your PowerPoint answer sheet and on the Scenario 1 slide, illustrate how you would have drawn this tornado warning polygon. Pause this video until you are ready to go on to the second scenario. Here is scenario number 2. Your focus is on the newly issued tornado warning polygon with the double borders. This was issued well in advance to give more lead time to the upstream portion of the polygon, an important consideration especially when dealing with a high-end threat. How might you have drawn this polygon, given a steady northeast motion as given by the straight white arrow? The storm has already deviated to the right of the mean wind and has been moving in its current direction and speed for a considerable period of time. Assume that the upstream polygon will expire as the mesocyclone, shown by the curved arrows, gets to the downstream tip of the storm motion arrow, or just east of the town of Hornersville. Pause this video to mark your answer in the answer sheet on the scenario number 2 slide. Here's an interesting scenario with a very slow moving storm with rotation that appears to have a marginal tornado threat based on the report of a funnel cloud extending close to the ground. The hazard is located along the southwestern border of the tornado warning polygon that's shown. The storm is drifting northeast at just 5 miles an hour due to weak steering flow. A 30-minute tornado warning text product is shown. How many examples of erroneous or potentially confusing information can you find from the polygon or accompanying text product? I'll now show you a map with the communities within the polygon area. The storm core location is shown in red, and the expected storm motion over the 30-minute period of the warning is illustrated by the black arrow. Pause this video and provide your answer in the answer sheet on the scenario number 3 slide. I will once again show you the warning, polygon, and text product. Check out this radar animation, showing images every 10 minutes for a 20-minute period. Notice the rather messy display of polygons in this case. This can lead to confusion, with locations under severe thunderstorm warnings, then under tornado warnings, then back under severes. Here is the final radar image of the animation for this scenario. This is quite a confusing mess of polygons. Based on the image to the left, how could you clean this up? What adjustments to existing polygons would you make? And any new ones you would issue to improve the end result, one that shows exactly where the hazards are and where they're going at this moment in time, without having considerable polygon overlap. Pause this video and indicate your answer in the answer sheet on the scenario number 4 slide. Here is scenario 5. We have 3 tornado warning polygons marked 1, 2, and 3. Number 1 is the oldest warning, but will remain in effect until the storm clears it. Number 2 is the newest one, and number 3 is for the more downstream supercell. How might these have evolved to minimize polygon overlap? The downstream supercell is moving slightly north of east, while the upstream storm is moving slightly south of east. How would you update these polygons and issue additional ones if needed so that you don't have considerable polygon overlap? Pause this video and indicate your answer in the answer sheet on the scenario number 5 slide. On to scenario 6, which will be the halfway point of the exercise. This is another interesting tornado warning case. Focus on the newer tornado warning polygon, the larger one, and its associated text product shown here. Issued 30 minutes after the first warning that's shown. Note that the first one remains in effect for another 30 minutes. The new polygon is focused on the lead circulation northeast of Dakota City, but is drawn to also encompass a second circulation further to the west. What aspects of the polygon and text product are either wrong or potentially confusing? On this image, the towns are hard to see, so the next slide will have a better illustration of the towns within the new warning polygon. Your task again will be to show how you would draw the new polygon, as well as to list the errors or confusing aspects of the polygons or the text product. Here's a map showing the towns within the new polygon. Pause the video and go to your answer sheet, scenario number 6 slide, to provide your answers. Here is scenario number 7, a summertime pulse severe storm case for a single storm moving very slowly east-southeast at about 10 miles per hour in a weak flow environment with the potential for downburst winds. Although a 60-minute severe thunderstorm warning polygon is shown, keep in mind that these single cells tend to have life cycles that last 15 to 30 minutes. How would you draw this severe thunderstorm warning polygon to best reflect the area in danger during the warning period? Pause this video and provide your answer on your answer sheet, scenario number 7 slide. The next scenario is for another summertime pulse severe storm case. This is for a single storm moving very little, maybe 5 miles per hour to the east. Note the impact of minimal shear with a circular cell and the highest reflectivity nearly in the middle. This slide shows the 45-minute severe thunderstorm warning polygon and text product that was just issued. The primary threat here is for downburst winds up to 60 miles an hour, along with possible large hail, though for the straight up and down storm with no shear, hail melting will be considerable, which will cool the downdraft and boost downburst potential. What issues do you see with the polygon and text product, and how would you draw the polygon to potentially resolve these issues? A map of the warning area is shown to the right, with the green oval representing the location of the storm core. Pause the video and indicate your answer on your answer sheet, scenario number 8 slide. Scenario number 9 represents an interesting issue that is occasionally observed. We have a warning for an east-southeast moving supercell. There is strong westerly storm top shear that spreads a broad anvil down shear. However, the cloud layer mean wind is weaker and the initial storm motion is not very fast. This supports greater impact of the propagation vector in turning the storm more to the southeast. And as you see here, it gets the storm out of the initial warning polygon. Yikes. With potential for up to 2-inch hail and damaging winds, clearly we need a new severe thunderstorm warning pronto. Pause the video and indicate on your answer sheet in the scenario number 9 slide what actions you would take if you were the warning forecaster on duty. We have reached scenario 10. The left image is a severe thunderstorm warning covering 2 storms with potential for producing damaging winds. Note the rear inflow notches where damaging winds could be occurring. The right radar image shows the event ongoing with no change to the polygon for a SVS issuance. How would you update the polygon to focus on where the danger exists at the time of the SVS that's shown on the right radar image? Also, do you see any issues with the warning that was issued as shown on the polygon in the left image or the text product that's shown? Pause the video and complete these tasks on your answer sheet scenario number 10 slide. For scenario 11, we have polygons for an event from 2 adjacent WFOs, but we're going to assume they're all covered by one office. This is a tricky case dealing with mesovortices along a QLCS. As you can see, the southernmost purple tornado warning polygon was just issued for a new mesovortex, but overlaps much of the northern tornado warning polygon, which will remain in effect until the storm's exit. How could the polygons shown in this image have been drawn or updated to provide an easier to interpret result? And this covers all the polygons shown. Pause the video and draw your answer on the image on your answer sheet, scenario number 11 slide. All right, we have reached the final scenario for this exercise. Here we have a long-lived tornadic supercell moving steadily northeast as shown by the white arrow. An SVS was just issued as shown on the right, but the polygon was not changed. How might you have adjusted the polygon to focus it on areas in the path of the hazards? Note that while not shown here, there's a TDS at the base of the hook feature, where the mesocyclone is located, as highlighted by the curved arrows, with a large BWER feature over the inflow region to the west-northwest of Ridgely. Also, what errors or confusing issues of the polygon or text product can you find? Pause the video and complete these tasks on your answer sheet scenario number 12 slide. Congratulations, you have completed the exercise. Now it's time to score your answers and find out if you executed practically perfect polygonology or if you're a candidate for polygonology therapy. You will self-score your answers based on the instructions provided in the answer key video. Now, this is not a competition, so be as honest as you can regarding your answers. Based on the answers provided, do you have a better sense of what issues to look for prior to transmitting warnings?